all are doing good. I am Saloni Narang. I am Docker Captain, CNCF Ambassador, and co-founder of KubeSimplify. There is a lot to be discussed today, so let's get right into it. So the title of our panel is Running AI Workloads in Wasm. Is it production ready? Today we have Shivay from Couchbase, Michael Yuan from Second Stage, and the famous WasmEdge runtime project, Saiyam, principal developer advocate at Loft Labs, and creator of Wasm course. Then we have Radu from Fermion, who are creators of Spin and SpinCube. So remember the first talk of the day? Who all remember? Okay, well, this is Wasm I, and it's about Wasm ready for enterprise. And Eduardo and Andrea portrayed a beautiful story over there this morning. And I want to take things in continuation with that, but with the AI angle to it. Well, we need to have the AI angle, isn't it? So we have witnessed a rapid rise in adoption of generative AI across industries, pushing the boundaries of what's possible in machine learning and beyond. Today, we'll explore the current state of Wasm in this ecosystem, how it's enabling efficient, scalable, and sustainable AI inference. Whether it's truly a game changer for production workloads, we'll cover its application in edge computing with projects like LlamaEdge, GAIA nodes, Kubernetes-based orchestration with SpinCube, browser-based inference with WebLLM, and even its potential in secure multi-tenant deployments. Plus, we'll peek into the future of AI agents and Wasm's evolving. Now, moving to the equations, I would first like to ask Saiyam and Shivay about the current generative AI landscape, what is happening, and how are you keeping up? So let's start with Saiyam first.
Okay, the introduction is on me for setting the context, which is fine. But setting the context we actually did. I hope you see the picture behind. And that's the Ghibli style image is the new trend, right? And how can we miss it at Wasm I as well? So yeah, if anybody doesn't know, AI is artificial intelligence, just in case. And generative AI means it is able to generate new content, text, image, code out of the input that you provide to the models. So the Gen AI ecosystem, why it became popular, well, it's well known kind of now, when ChatGPT came in, GPT like generative, pre-trained transformer. So generative is predicting the next word on the pre-trained set of LLMs using the large, the text that it is trained on, and then transformer being the algorithm over there. So with that, there has been a surge in people. Like this is the first time I have seen, not the first time, but very rarely we see a technology that everyone who is in tech and non-tech using it. So that's why it became so widely spread, and there is no single conference where we do not talk about the AI ecosystem, about AI. Every product out there is trying to figure out how they can cater to the needs of AI or provide the application to the AI ecosystem. So yes, AI is riding, you sleep, you wake up in the morning, and there is a new model out there. So that's how the AI ecosystem is being developed. So we were on the way to Wasm I, and the Ghibli style images are trending suddenly on the internet because there is a new revolution in the image generation. The text to image has gone to next level. So just a few days back, if you went on ChatGPT and tried, put this text on this particular image, it would fail miserably. But now if you do it, it's doing really well job, even capturing the details from an existing image, which is very, very interesting how fast the landscape is evolving. And I think whether you are that's what I believe, whether you are in the ML ecosystem or in the non-machine learning ecosystem or background, knowing about this technology from your own area of expertise is important. Let me give you my example. I come from the cloud native and the Kubernetes background. For me, infrastructure is something which is very important. So although I use AI for all my stuff, in helping out productivity and all those that everybody is doing, but for me, from an infra person, I believe that I need to know how stuff works, how I can make the models, the inferencing available to the machine learning engineers, how I can provide the best-in-class infrastructure with Kubernetes to the AI engineers, so that the infra level layer is something that I focus on, and how I cater to those AI workloads. So like this, everyone kind of does this in their own way, and how I keep up with the landscape is pretty simple. Since again, same repetitive stuff, I'm from the cloud native background, so there's a cloud native AI group. There are social media, there are some newsletters that you can follow for all the stuff that is happening in the AI ecosystem. But yeah, I think it's important to kind of get updated and stay up to date in the AI ecosystem.
Yeah, and I think just to kind of piggyback on what Saiyam mentioned, another growing trend that we are seeing is with agentic AI, right? So we are seeing that now it's not just these LLMs that were trained on this data and they were only able to actually generate text, but we are now seeing that when you add the capability of being able to actually give tool calling to the LLMs, where now they're able to access databases or they're able to access external APIs, the kind of functionality that you can actually get out of these particular agentic systems is pretty tremendous. And we'll see specifically throughout today's particular panel that how, when it comes to making more efficient compute, because ultimately we know that whenever you're trying to execute any AI workload, there is a lot of compute at play. And when you're trying to execute these particular workloads in systems that are typically not as performant, like such as the browser or the edge, how we can actually do that more efficiently and also in a more sustainable manner with the help of WebAssembly. So I don't want to take up too much of the time, because the crux of what we want to cover is basically what we'll talk about later. But you'll see these trends around agentic AI, LLMs, and how we are doing them more efficiently with the help of WebAssembly across a diverse set of use cases. So whether you're working in an edge company or you're working building applications securely in the browser, how WebAssembly is being used there to run these AI workloads.
Well, those were some great insights. As we all know now, most developers prefer to use Python AI ML for AI and ML. So my next question is to Michael and Radu. So what are your thoughts on the languages used in AI ML space? What does the landscape looks right now? Is Python still dominant or most performant? Is it most efficient language for the Gen AI workloads, or there are another languages, frameworks which can be used? If yes, then tell us how and where. Let's start with Michael.
Oh, thank you. Yeah, so I have conflicted feelings about Python. That's because I think I'm a little bit known. One of the most popular articles I wrote on Medium, that has over, I think, 500,000 views and thousands of comments, is I say the language of AGI is Rust. That's actually not my quote. That Elon Musk said that. So one of the key points that we want to make is, although Python is very popular, all the models are released as PyTorch weights initially. It actually not that popular in real time, in real production workloads. In production workloads, when people run LLM, I see 90% of them are either running Llama.cpp or VLLM or SGLang. All three of them are C, C++ based frameworks. Nothing to do with Python. Python is just used as a front end, So because all those, today's AI inference workload, and another data point I want to give you is that if you see a new open source model released on Hugging Face, you can go look at the download counts. The Llama.cpp's format, which is GGUF format, those files are downloaded 10 times more than Python format the day in a week after it's released. So I thought that was very enlightening. Is that although Python get a lot of mentions and a lot of mind shares, but I assume when it comes to inference, most people don't use Python to do inference. Most people actually use one of the C++ based frameworks. And I think that is one of the drivers that opens us up for using Wasm to run C++ code, because we know it's hard to run Python code, especially the Python ecosystem in Wasm, but C++ is an entirely different story. So, so that's, what I would say is the origin story of why we use WasmEdge to do AI inference.
Yeah, I think I'd split the question into what do most people reach for the first time when they're trying something out, and what's the most accessible language out there, and what do people use when it's time to move to production, and what are the new kinds of inferencing engines using. And when talking about accessible languages and tools that make it easy for anyone to start prototyping something, Python, I don't think, is going away anytime soon. The simplicity of being able to fetch a built-in library and just use it to generate inferencing, I think that's largely going to remain, and it's an awesome language, and it's something that, people from high school all the way through companies can learn and use in real things. One of the things that has been happening over the last, I would say, 3 years or so is I see a lot of inferencing engines built in Rust rather than Python. And I think for some of the same reasons that Michael was talking about C++ being used, the memory safety of that Rust brings to the table is something that's very, very inspiring confidence when running in production. And so if you look at some of the new frameworks that are coming out of Hugging Face, Candle is a very, very popular Rust framework for building machine learning applications. And I think a couple of weeks ago, NVIDIA announced another inferencing server also built in Rust. And so I'm kind of biased when it comes to Rust. It's one of my favorite programming languages, and we build a lot of things in Rust. But I see a lot of people doing Python when it comes to prototyping, and I see a lot of big companies putting their eggs in the Rust basket for real production-grade systems.
Yeah, so now we all know that generative AI landscape is massive, and there is room for different programming languages based on the different use cases. Time for what you have been waiting for, WebAssembly. Let's understand where WebAssembly comes into the picture when we talk about Gen AI. So Michael, coming back to you, to understand when it comes to AI or AI inference, which means when the end user is trying to access a particular model, where Wasm comes into the play.
Well, ironically, I think Wasm's role played here is very similar to Python's role played in the ecosystem, is to make two abstractions. One is to abstract away the hardware, because one thing unique about AI inference is that there are so many GPUs, so many accelerators and all that stuff, right? For developers to target each platform is very difficult, so you really need a truly write once, run anywhere solution, meaning that I write my inference code once, and I expect it to run on, I don't have on AMD, on NVIDIA, on the Mac. I don't have to tell it it's CUDA 11.5 versus CUDA 12.4. They should be all the same code. There shouldn't be any difference. Python handles it very well. But if we don't have Python, we go to the C++ land. All this has to be hard-coded again. So Wasm, I think, on one hand, solves this abstraction. So it provides a write once, run anywhere across GPU architectures, especially on the edge, right? On the second abstraction is the model abstraction. The model abstraction is also what Python solved, but C++ doesn't solve. Is to say, I have different model architecture. Some are large language model, some large language model can handle pictures, like the one that we just saw, right? Can handle videos. Some are text to speech, speech to text, image generation, and all those models. I need a consistent way to run all of them and provide, so I don't have to handcraft the code to manipulate the tensor and do that. So again, the traditional PyTorch framework solved this problem very well, but not the C++ framework. In order for, I think high performance inference on the edge that is more friendly to developers, I think we need to have those two abstractions. Abstract away the GPU and the drivers and all that stuff, hardware-related stuff, and abstract away the model difference. And I think Wasm in this, in those two particular areas, and Wasm does it very well. So because it is an intermediate runtime framework that's set between hardware and software, right? So it's sort of like the old days of the JVM, right? You have a bytecode format that that looks the same to developers. You just compile it once, and at runtime, the Wasm runtime figure out which GPU it's running on, what version of CUDA, what version of the Mac Metal framework, and what model it's running, and then translate it accordingly, right? So I think that's at least from my point of view, that's the biggest reason why why our developers use Wasm is to have a consistent developer user experience, but in languages like C and Rust.
So I would go back again to Radu, and I will ask, can you also provide why Wasm for AI inference is the go-to choice?
Yeah, I think the one thing that I'd start with is I'm not necessarily old enough, but I've worked within with machine learning well before it was the AI hype around that we see today. And one of the very first things that I did with WebAssembly was building an inferencing engine for classical machine learning models. And the reason there was there were these machine learning models that needed to be executed independently of CPU architectures and operating systems. And to Michael's point, abstract both the model itself, but also more importantly, the hardware behind the scenes. And so that is really the big draw that I see people come to WebAssembly when it comes to inferencing is, making sure that they can run reliably and consistently a program across various operating systems, CPU architectures, but also GPU implementations as well.
And just to probably touch upon what Radu mentioned, if you look at one classic example of a MobileNet model, if you look at the size of the model and the inference times when you're comparing it with running it in classic Python in a Docker container, or you're looking at running it with Node.js, you'll consistently find that because of the ahead-of-time compilation strategies, and of course a smaller bundle size that you get with WebAssembly, it will consistently be not only the quickest in terms of execution, where you'll probably find like it's even running faster than native Python, but also have a much smaller size. So I think those are some of the capabilities that also enable you to package your models in a more efficient manner and run them in these smaller edge compute, whereas if you were just running them with traditional Python, it would have taken a lot more space as well. So I think that's also one consideration, especially if you're trying to run machine learning inference across different types of device architectures, where now you're not just concerned about the underlying GPU or the CPU architecture, but also from a compute speed and how small these models are.
So Wasm is right now proving to be a very efficient choice for the AI inference with all the benefits it provides. Let's switch the gears to production now. We have seen that Wasm is stable, used in production for many of the use cases. Like last year, Google also presented how they are using Wasm in all their products, AI products basically. So let's discuss some of the use cases for Wasm in production with the AI angle. For this one, let's spend some time with every one of you, and let's start with Michael first.
Me again? Okay. Well, so, so we have a lot of customers, or, I wouldn't say, as a company we have customers, but open source project we have a lot of users that is using, so the primary use case really is to use Wasm to run AI locally on your own machine, right? So you would ask, what's other use cases for that? So there's lots, so from the a hobbyist or developer point of view, I often there's a new open source model that come out that I need to run it myself. That's so which is there are lots of tools like that. A lot of people use LlamaEdge, but there's also Llama and things like that where you run it on your machine, right? But I think some of the more interesting use cases in our observation are like on the edge. So for instance, there's one example that I talked about before. Last year we had an event where one of our users at UC Berkeley came, and what they did is that they have a laptop and a drone. So they use a large language model to control the drone. So how it works is that So large language model, when you speak natural language to it, it will come back with natural language, right? But they fine-tuned the model so that it doesn't respond in natural language, it responds in Python, right? So the Python is built with the drone SDK. So it can automatically generate the Python and it controls the drone. So I have to tell the drone, tell me what's behind that wall. And it will generate the Python code to say, take off, fly 10 meters ahead, turn around, take a picture, and come back, right? So it would be the response the large language model gave, right? For use cases like that, it's all local, it's all edge. And, so that would be one of the, interesting use case for, why would you want to run large language model use Wasm engine, right, in some of those edge devices. And today, LlamaEdge runs on, say, the NVIDIA Jetson, chipset. It runs on Raspberry Pi. That's using the ARM accelerator. So it runs all kinds of different models. And there's many other use cases I don't think we have for time to discuss. But personal coding assistant is one of the other ones, right? That's you use the large language model. You run like Chairman Coder with your own code base or your private code base and have it answer your questions and plug into Cursor and things like that. So yeah, there's we also have fairly large use cases where one of the leading short video platforms in America wants to have a transcription for all their video. The reason for that is for recommendation engine, because recommendation engine work off text. So you need to know what's text in the video or is it music or things like that. So we built a customized LlamaEdge pipeline for them. It's handling 700,000 videos per day. To have all those videos come in and have 2 or 3 models work on extracting the audio, extracting the feature, break into sentences, and then do the transcription, and use a large language model to check the transcription to see if it's done correctly, and then assemble them back together. It's an entire pipeline of multiple models, multiple applications, all written in Rust, and run the Wasm platform. I can go on, but I think I should stop. That's.
Yes, Saiyam.
Yeah. So when we talk about coming from the last year, so last year the Fermion folks and some of the open source community, they launched SpinCube. So SpinCube is a project that lets you run, create those Spin applications and run it on Kubernetes clusters. So we know the benefits of WebAssembly is something that you all have been hearing, the universal bytecode, write once, run anywhere kind of things. And Kubernetes is a base platform. It has become so stable, and some people call it boring as well, because when a tech becomes boring and standard, it becomes stable. That's what it means. So now you have Kubernetes as the base layer, and now in the WebAssembly ecosystem, you have this a path where you can have your WebAssembly applications or WebAssembly functions that are created, and you can run it on those Kubernetes clusters. Now, with AI ecosystem, it makes even more sense. Now, if you remember the first talk, it's not about replacing the containers. It's about actually running them side by side. It's about you have your base Kubernetes cluster, you have your infrastructure with you of running anything that you want. And Kubernetes is not now a container orchestrator only. It can orchestrate VMs, it can orchestrate any resource based on a lot of CNCF projects like Crossplane and stuff. But with the tools, open source tooling like SpinCube, which is also part of CNCF, it lets you easily create those workloads, have those access the inference, the AI models to inference that, and having that privacy as well, because Wasm runs in those isolated sandboxes, you define how much access has to be given based on the components, the level of access that you define within those WebAssembly modules, and then you run it on your Kubernetes cluster. So now you have a platform, so it leads to the adoption barrier, there is less adoption barrier now, because you don't have to change the infrastructure that you are having, you are still using the same one. And AI is coming in. There are tools within the WebAssembly ecosystem that everyone wants to use for AI inferencing, as we heard from Michael and Radu as well. So now you can use them because you don't need a new infrastructure. You have your clusters already in place. Now you just need to annotate them, have the shims, the new shims onto that with the WasmEdge or the another runtime that you are having, so that when you are running it, you can use the new runtime class specified in your YAML specification, and that will use the new shim. That's the power of containerd. And then with the AI inferencing power, it can use something which is running like, the GBs of model, access that, which are pre-hot, and get those inference. I think I and Radu last year gave this talk and a demo where we had a Kubernetes cluster spinned up and we created the new application connected to the Spin Cloud, and it already had those large language models out there, and it is able to use the GPUs attached and give you the output immediately. So I think that's where the infra Kubernetes role play an important role in production using some of the toolings that the Wasm ecosystem has created.
Yeah, I think like probably keeping in the time as well, I'd like to also probably just quickly touch upon some of the other use cases on the browser. So as we know that most of today's generative AI applications, or in general, most of the applications that we interface are either on your mobile, but mostly they're on the web. And one of the biggest issues that we have to deal with is privacy, right? So if there are companies that are wanting to, probably it could be healthcare or insurance companies that don't want to send their privacy data to these servers or these OpenAI models. Or perhaps their use case is very simple, where having the cost of a hardware accelerated with a server, it doesn't justify. So today, the thing is that now, over the past 5 to 6 years, the browser ecosystem has evolved so much that we have ecosystem within the help of WebAssembly and technology like WebGPU, which can allow you to run your AI workloads directly into the browser. And there are already companies like as big as something like Photoshop, where Adobe Photoshop uses TensorFlow.js project under the hood for doing real-time editing capabilities of images directly in the browser, where the model will get downloaded into your browser, and with the help of Emscripten, where it allows you to translate your C++ code into WebAssembly and then run it inside of your browser environment with the help of JavaScript. To a lot of other smaller startups also actually adopting it. So if you're using something like Google Meet, it uses WebAssembly for doing the background removal or adding a virtual background. Or there are healthcare companies where you can do like online physiotherapy by leveraging the online webcam. And the great thing about the web ecosystem specifically is that you have such a huge ecosystem of tooling that you can technically also build your own entire RAG pipeline by running vector databases directly into the browser, running web LLM today, which uses a combination of your WebAssembly and WebGPU, because of course, while we know that WebAssembly is really optimized for CPU-based workloads, and a lot of these simple machine learning models, because today in GenAI ecosystem, we tend to forget that you have your traditional models as well, which can run very effectively just on your CPU. But if you are trying to run more of LLMs, then you can very easily hand off because of the good interop between WebAssembly and WebGPU, where most of your tasks or the tensor processing for your machine learning workloads can be handled with the SIMD, which is supported by WebAssembly. But any other high compute for LLM inferencing can then be taken up by the WebGPU. So by using a combination, you can actually just run simple, 1 billion parameter model or 2 billion parameter based Gemma models directly into the browser. And that gives you the capability of running it completely offline. It's you're not running into any cost because it's on your device. The latency is something that you are also able to save on. So these capabilities allow you to give a lot of flexibility to customers who are wanting privacy-first applications. And that's why, not just the web ecosystem, but now we're also seeing it extended to MCP. So of course, a lot of you might have probably heard of the Model Context Protocol. So folks from Dialypso, they showed it during their initial keynote presentation as well with the MCP.run, where they have built this entire ecosystem of being able to bring in MCP server compliant applications and registering them and serving them as WebAssembly executables in a more secure manner, where you can just build any sort of application that can interface with these LLMs and do efficient tool calling. So what we're seeing is that whether you talk about running secure applications on the web or you're talking about running agentic applications, WebAssembly is the go-to choice when it comes to whether edge compute or browser. And probably, I know, like we are running a bit on time. If Radu, if you want to add to it.
Yeah, so we are running out of time. So Radu, can you please merge the use cases and closing thought together for our audience?
Sure. I think one of the most important things to keep in mind is why would you use WebAssembly for something? And to me, the immediate answer to that is, well, you need something that runs in a sandbox, in an isolation context. And Saiyam's point about model context protocol and agents in general is a really, really good topic. I think I'd add one more idea that hasn't been said so far here, which is there's a lot of serverless needs for things like retrieval augmented generation and glue code, if you want to call it that way, where you actually have to run something very fast and execute sandbox code as well. And so really, if you need, not even just for inferencing, where Michael's been work on LlamaEdge is encompassing a lot of the generate inferencing from WebAssembly, but even outside, whenever you need to execute something in a sandbox environment, WebAssembly is becoming a really, really good choice there.
Okay, so well, as I had more questions, and I'm sure you all must be having, so they are all around here. You can ask your questions from them. So thank you all for this panel, and see you.
Thank you.
Thank you.